Assalamu alaikum. How are you, students? Hope you all are fine and safe by the grace of Almighty Allah. So welcome back to my physics class, dear students of Standard 9. Today I will explain some topics from the chapter that is named Effect of Heat on Matter, that is chapter 6 of your physics book. So let's start the class. Dear student, here is my identification. Me Mafru Shati. Today I am going to explain change of effect of heat on change of state, thermal capacity, principle of calorimetry. So I will explain 3 topics today, and those are very much important for you. From those topics, MCQ, then realization based, knowledge based question can come. So be very careful to watch my content and try to make your base strong. Okay, the first topic, effect of heat on change of state. You know, by the application of heat, the state of substance can be changed. So at first, let's read this one. Matter can exist in 3 states, you know, solid, liquid and gas. All of us know that water has 3 states, ice, water and vapor. These 3 states are called solid, liquid and gas. These states of water depend on air pressure and temperature. A solid may be liquefied by applying heat. This process is called fusion. That means fusion is the process where a solid turns into liquid. At the beginning, the temperature of a body rises with the application of heat, and at one stage the temperature does not change even if more heat is applied. So question may arise in your mind, then where does this heat go? At this moment, the amount of heat absorbed by body is used to convert the solid into liquid only. That means when the solid is turning into liquid completely, that time the temperature will not rise, but the absorbed heat will be used for breaking the intermolecular bond among the liquid molecules. So if heat is applied to ice below 0 degrees Celsius, temperature will rise and reach at 0 degrees Celsius. You know, the melting point of ice is 0 degrees Celsius. So at 0 degrees Celsius, the ice starts to melt. After this, if more heat is applied, the temperature will not rise, but the ice will begin to melt to water. This amount of heat absorbed during the conversion of a solid to liquid is used to break the intermolecular bond of the molecules that I have told you. On further heating, the temperature of water of 0 degrees Celsius starts to rise. At a stage, that means 0 degree ice will be converted into 0 degree water. Okay, then when the water of 0 degrees when the temperature of water becomes 0 degrees Celsius, then again the temperature starts to rise. At a stage, water starts vaporizing and the temperature remains unchanged until the complete water converted into vapor. So at that time, the heat absorbed will be used for breaking the intermolecular bond. So during this time, water absorbs heat to become vapor. Here also the effect of heat is used to break the intermolecular bond among the liquid molecules. On the other hand, on the other way, around gaseous substance may be converted to liquid and liquid to solid by extracting heat from them. So on transformation of substance, effect of heat is remarkable. So here one question can come, what is latent heat? The heat required to convert a solid into liquid or vapor, or a solid or a liquid into vapor without change the temperature. That is known as latent heat. So latent heat is that heat which only changes the states of matter but not rise the temperature. That heat is called latent heat. That is in Bengali called as shupto tap. You know, shupto means ঘুমন্ত বা মানে যেটার কোনো এফেক্ট নাই। Look, there is a graph for you. Try to understand it. In this graph, we are seeing with application of heat, the temperature is rising. Look, when into a solid substance heat is supplied, then its temperature will rise. That means suppose here ice is taken, okay? So when temperature will rise, then at first temperature will rise. When the temperature reaches to 0 degrees Celsius, then we can see from here to here there is no change of temperature, but heat is supplied, heat is applied in this position, but temperature will not rise. So this heat is known as latent heat, and this heat is used to break the intermolecular bond of the solid substance, and in this position the solid turns into liquid. Until the solid turns into liquid, the temperature will not rise. So here we will apply heat, but the heat is not used to raise the temperature, rather it is used to break the intermolecular bond, and that heat is known as latent heat of fusion. Then again, when the solid turns into liquid, again temperature will rise, but after a certain period we will see temperature is will not rise. Okay, that time we get latent heat of vaporization. Until the liquid turns into vapor, the temperature will not rise. Temperature will be steady in this position. When the liquid turns into vapor, then again temperature will rise. In this way we will get this graph. Have you understood the graph? Now I will explain dependence of evaporation on various factors. Evaporation depends on the following factors. Let's look which are the factors on which evaporation depends. Flow of air. At first, flow of air. The speed of evaporation increases if the air flow faster over the liquid. The area of the exposed surface of the liquid. Evaporation increases as the area of the exposed surface of the liquid increases. Suppose if you take some water in a bowl and take some water in a bottle, so in which case the evaporation will be more, while the exposed surface will be more? Obviously in case of bowl of water. So in case of bowl of water, we are seeing the exposed surface is larger, that's why evaporation will be more rapid. Nature of liquid. The rates of evaporation of different liquids are different. Less the boiling point of a liquid, more would be the rate of evaporation. The rate of evaporation of volatile substance is maximum. Volatile substance, you know, volatile substance from solid directly goes into gaseous state, and the rate of evaporation of volatile substance is the maximum. Pressure on the liquid. The rate of evaporation decreases with increase of atmospheric pressure on the liquid. The rate of evaporation increases with the decrease of pressure. The rate of evaporation in vacuum is maximum, because in vacuum the atmospheric pressure is very low, nearer to 0. That's why the evaporation rate will be maximum. Liquid and the temperature of the air in contact with the liquid. If the temperature of air in contact with the liquid increases, then the rate of evaporation will increase. Effect of dryness. The more the dryness of the air over the liquid surface, such that the less the amount of water vapor in air, more will be the rate of evaporation. That means when there will be less water vapor in the air, you know that air is known as dry air. So if dry air flows over the liquid surface, then evaporation rate will be more. The soaked cloths dry up quickly in winter because air remains dry at that time. You know very well that during winter season there is less amount of water vapor in the air, and that's why the air becomes dry, and in that dry air the soaked cloths dry up very quickly. So these are the factors on which evaporation depends, and I will tell you, you must memorize these factors. This can come as your MCQ and also knowledge and realization based question. Now I will explain thermal capacity. The amount of heat required to rise the temperature of a body to 1 Kelvin is called heat capacity of the body. That means the heat that is required to raise the temperature of a body by 1 Kelvin is called heat capacity of that body. The heat capacity depends on the material and the mass of the body. Its unit is joule per Kelvin. The heat capacity of a body is 10 joule per Kelvin. It means 10 joule heat is required to raise the temperature of the body through 1 Kelvin. This type of significance can come into our exam paper. That means, what does it mean if the heat capacity of a body is 100 joule per Kelvin? So you can explain in that in this way, that if 100 joule heat is required to raise temperature of the body to 1 Kelvin, then the heat capacity becomes 100 joule per Kelvin. So this is the definition of thermal capacity. You must memorize it. So let Q amount of heat is required to increase the temperature of a body through del theta. Therefore, the amount of heat required to raise the temperature of the body through 1 Kelvin is what? Q by del theta. That means for raising del theta temperature, Q amount of heat is required. So for raising 1 Kelvin temperature, Q by del theta heat is required. In this way, we get C equal to Q by del theta, where C is the thermal capacity. Here, the unit of thermal capacity becomes joule per Kelvin, because you know Q, that is amount of heat, and heat is a kind of energy, and any kind of energy is measured by the unit of joule. So the unit of heat is here joule, and del theta in Kelvin scale. In SI system, Kelvin is the unit of temperature. So the unit of heat capacity will be joule per Kelvin. Now I will explain specific heat. The amount of heat required to raise the temperature of a body of mass 1 kg. Dear students, underline this one, mass 1 kg. Heat capacity and thermal capacity. Heat capacity and specific heat, these two definition is very identical, except one difference is here. In case of heat capacity, we don't tell about any mass. Heat capacity is of any mass, but here we declare the mass should be 1 kg. So the amount of heat required to raise the temperature of a body of mass 1 kg to 1 Kelvin is called the specific heat of the material of that body. It is denoted by the letter S. So I have told you heat capacity and specific heat is similar, just one difference, there is a mass, the amount of mass is declared in case of a specific heat, and in heat capacity a mass is not counted, because C equal to Q by del theta. So S equal to, we can write mathematically, we can express specific heat S equal to C by m. Okay, so we can write 1 by m into C equal to q by del theta. So it becomes q by m del theta. So q equal to, from here we can write, if a specific heat is given in the question, then you will calculate the amount of heat by this way, q equal to ms del theta by cross multiplication. This s will be multiplied with this m del theta, then it becomes q equal to ms del theta. So this formula you will require to find out the amount of heat when specific heat is given in the question. The unit of specific heat is joule per kg per Kelvin. Here is also the difference of unit between specific heat and heat capacity, because you know, in case of heat capacity the unit was joule per Kelvin, and here as the mass is declared, so here the unit will be joule per kg per Kelvin, because you know in SI system the unit of heat is joule, unit of mass is kg, and unit of temperature is Kelvin. So it becomes joule per kg per Kelvin. So there is a significance for you. The specific heat of lead is 130 joule per kg per Kelvin. What does it mean? It means 130 joule heat is required to raise the temperature of 1 kg lead, 1 kg of lead through 1 Kelvin. So here C equal to heat capacity, Q equal to absorbed heat, del theta is increase of temperature, m is the mass of the body. Now we will discuss between the relation of specific heat and thermal capacity or heat capacity. Thermal and heat is same. We know the amount of heat required to increase the temperature of a body through 1 Kelvin is called heat capacity or thermal capacity. Again, if the specific heat of the material of a body is S, then S joule heat is required to raise the temperature of the body through 1 Kelvin. Therefore, to increase the temperature through 1 Kelvin of a body with mass of 1 kg, the amount of heat required is S joule. So to increase the temperature through 1 Kelvin of a body with a mass of m kg, the amount of heat required equal to ms joule. For 1 kg object, to raise temperature 1 Kelvin, S joule heat is required. So for m kg object, to raise 1 Kelvin temperature, ms joule heat is required. Just unitary method. Okay, ms joule. And you know, the heat required to raise 1 Kelvin temperature of m kg of any substance is known as heat capacity. So we can write it is the heat capacity of the body with a mass of m kg. So heat capacity C equal to ms joule. That means C equal to mass into specific heat, or specific heat equal to C by m. That means heat capacity by mass. So if you have specific heat, then you will multiply the mass with it to get heat capacity while doing the mathematical problems. Again, heat capacity equal to mass into specific heat. So specific heat equal to heat capacity by mass. So it is the relation between heat capacity and specific heat. So in this way, this question can come, that means explain the relation between specific heat and thermal capacity. Then you will explain that question. That may come in your B number question that carries 2 marks. In this way you can explain it. Dear students, now I will explain fundamental principle of calorimetry. When two bodies of different temperatures are brought in thermal contact, then reception and donation of heat take place. The body at higher temperature leaves heat, whereas the body at lower temperature receives heat. This give and take will continue until they reach at the thermal equilibrium. If no heat is lost during donation and reception of heat, then the amount of heat given up by the body at higher temperature will be equal to the heat gained by the body at lower temperature. Dear students, I am to give you one example. During winter season, you take hot water to take bath, isn't it? So, you at the time you pour some hot water in the bucket of cold water. So, when you will pour the hot water into the bucket of cold water, then what will happen? Then the hot water of high temperature will lost heat, lost heat, and the cold water which is at lower temperature will receive the heat, and this donation and reception of heat will be continued until the two bodies, that means two water, hot water and cold water, that means the mixture of the water will reach to the room temperature, that means will reach to the thermal equilibrium. So if no heat is lost during donation and reception of heat, then the amount of heat given by the body at higher temperature will be equal to the heat gained by the body at lower temperature. So from here we can write the fundamental principle of calorimetry, that is heat lost equal to heat gained. So today dear students, today I am to finish my lecture. I think you understood my class, and in the next class I will finish this chapter, but before that I want to take a test of you up to today. What I have explained in that syllabus, I will take a test of you, and the test will be taken on 1st September, Tuesday. That means in the next week. So till then you will be safe, I think, and you will take your preparation. There is a moral for you. If the plan does not work, never change the goal, change the plan. Goodbye everybody.